Hey, so I'm going to show how we can build some Rust code and use it in Python. So first thing I'm going to do is go ahead and create a new project. And I'm going to call this Rust Python 1. I'm going to use a Python 3.5 interpreter and 64-bit one. There we go. So it's also a good idea to install the Rust extension for PyCharm. Now, first thing I'm going to do is go ahead and create this Rust folder. And in there, we need a cargo file. Might want to install the Toml plugin as well. So the cargo file is going to need a few things in it. Define the package. Create the authors section. Now we're just going to create a library called Hello World. So we create this lib section here. And we say crate type is C dynamic library. We want to use this PyO3 dependency. I'm going to use version 0.9.0. Then we want to create a release profile. There we go. Now we need a source folder. This is a Rust convention. And then we need a lib.rs file. Now, at this point, we can let PyCharm know that we have a cargo project by clicking attach here. And then find your cargo.toml file. That's it. Now it's going to run through updating a few things in PyCharm. This might take a while. All right, there we go. So let's create our Hello World program. So the first thing we need is to use some things from this PyO3 library. And let's create a Python module just like that. The module name is going to be Hello World. There we go. And it returns a PyResult. Okay, now let's create our Python function, the Hello World function. And we're just going to call it hi. This also returns a PyResult. This PyResult is going to be a string. And we want to OK a string. So S. Hello World. That's all we should need, and let's go ahead and try to build it. Okay, I'm gonna just quickly change my terminal to use Cygwin. This isn't necessary, but I always do it because I find Cygwin to be more comfortable for me. So I'm just gonna go into the Rust folder, and we have to type cargo plus nightly build release. Let's see if this works. Now if this works correctly, we should have a Python module with a hi function that returns Hello World. Okay, it finished, so let's see if we can actually use it. Should have a target folder. There we go, target release. Now what we want to do is copy this hello world.dll file that was created. We need to rename it hello world.pyd. Now copy that into the root folder of your project. And let's create a a main Python file. Now let's import hello world. From hello world import hi. And then let's see what we get when we call the hi function. Okay, so it said it can't import the name hi, and that's because we didn't wrap that function in the Python module. So we need to go m.add wrapped, and then wrap py function, and then just pass in the function to that. That should do it. Let's rebuild. Okay, this looks like it worked again. Hello world.dll, rename it. Copy that out here, overwrite. Here we go. Now let's run it again, and we get hello world. So it's really that easy. We've got Rust code being called from Python. So let's do something a little more interesting with this. Let's try to write a Rust sort function that beats the Python sort function. Okay, so first thing I'm going to change is this. I'm going to call this method, or this function, I'm going to call it quicksort. It's still going to return, this has to take in an array of values. So we want it to just sort a list in the same way that Python's sorted function does. It's not going to be exactly the same, but we're just going to sort numbers here. Okay. Now we're going to create a function called quicksort function. And then pass in the pivot points for the quicksort. So we want to go from 0 to the length of the array in the beginning for the first iteration of the quicksort. And then this is going to return nums. Okay, so that's the quicksort wrapper. So let's create we need two more functions. We need a partition function and then the quicksort function. So first is quicksort function, and we said this takes in our array, and then it's going to need the starting point and the ending point for the quicksort. So okay, our quicksort function doesn't return anything. It's going to just sort the values in place. And we're going to say if low is less than high, we need to get the pivot point from a partition function. And then once we have the pivot point, we want to call our quicksort function recursively for the left side and for the right side. Okay, so that's, we've got the skeleton so far, and I just need to create the partition function. This function does return something. It just returns the pivot point for the next iterations of quicksort. So let's go. So we're going to loop from the low index value to the high index value and check each value from low to high. And see if it's less than the pivot. It is. We increment I because that's going to be our new pivot point. And then we swap. Okay, and there's one final swap. And we're going to return the new pivot point. So that should be the entire quicksort function. We just need to change this to quicksort. So we're now wrapping quicksort. And let's try it out and see if it works. First, we need to build it. Okay, this looks like it built. Let's copy it. So now this should have a function called quicksort. And let's try to sort some data. So I'm going to just comment this line out right for a second. And so I want to show you what our data is going to look like. It's going to be a list of random numbers. So let's run that first. This is a list of random numbers between 0 and 100. Great. Now, Python has a sorted function called, that will sort this. So let's see what Python would do. Looks great. So now let's try our quicksort function. Let's see if it works. And it works. It sorted the numbers. So let's test out whether or not our quicksort function is faster than Python's built-in sorted function. So in order to do that, we need to use the timeit module. In order to use the timeit module, we need to set up some functions. There we go. Okay, so we're running time it twice. We're going to run our quicksort version and then Python sorted and see which one is faster. The time it module runs your function many times and determines how fast it thinks it is. So here we go. All right, so our Rust quicksort finished in 4.7 seconds and Python sorted function in 11.0 seconds. So this is pretty cool. But most of the time, Python code is going to be deployed to a Linux environment, and what we did here is on Windows. So let's put this in a Docker container and see if we can still get it to run. So what I'm going to do is create a Docker file. In this Docker file, we're going to use Python 3.5.9. So we need to install curl and build essentials in order to get Rust and then actually build things with Rust. And then what we're going to do is install Rust nightly, which is what we're using here. Now, in order to get that to work, after you do the install, it asks you to edit your path variable. So we're going to just do that here. I'm going to put all my code in this app folder. We're going to run the build command, the same one that we ran before. Now the output isn't going to be a DLL file, it's going to be a .so file, so we need to take that file and move it into the root folder. It's also going to have the word lib in front of it, so it's going to be lib hello world.so. We're just going to rename it to hello world.so. Great, and our command is python main.py. Now, I don't want Docker copying my PYD file or any of the target folder, so I'm going to create a Docker ignore file. There we go. So let's try to build this and see if the build will work and if we can run this in the Docker container. So right now it's installing curl and build essentials. Then it's going to install Rust up and cargo, and then install Rust nightly. Okay, now it's actually trying to build my project in the Docker container. So that's this part where I said cargo build release. Let's see how that goes. All right, it looks like the build worked. So let's try to run it in the container and see if it works. I think I called it Rust Python app. Yeah, okay, so I called it Rust Python app. And this is going to do the same thing. It's going to test whether or not our Rust quicksort beats Python's built-in sorted. We know that it was much faster on Windows, but is it going to be that much faster in Linux Docker container? So there we go. It worked, and our quicksort ran in 5.9 seconds. Python sorted was 9.4 seconds. So that's it. Thank you for watching, and enjoy using Rust with Python. Bye.